live.
So I mean, okay, no, I thought
So for when we set up the circuits, we have when we set the VGS to zero. So when we set the VGG to zero, the voltage from the so this VDD, is that drain to drain, or is that meant to represent drain to source? Guys, does the VDD represent drain to source?
VDD is from. I mean, technically, yeah.
And VGG is gate to source. I don't like this GG and DD.
They're the same. The reason why in this case is because the wire along the bottom, right? Like take VGS. VGG is like technically from here to here.
Yeah.
Right. VGS is from here to here, which is the same as here to here. So why are same as here to here? So that's why they're the same in this schematic. But like in other ones, they might not.
What do you mean that they're the same?
Because it's connected by wire.
Do you mean what? Sorry, repeat. I don't think what is the same. I mean.
VGG and VGS.
Yeah, I know they're the same. So I'm saying that why didn't they just name it VGS? That was my point.
Oh, he's found the schematic online, and I said VGG.
Yeah, I knew VGG and VGS were the same thing. I was like, yeah.
That's how you're gonna find it in the textbook.
Okay.
In the reading.
Okay.
Just like that.
The internet has seen your face.
Huh?
This is my face.
Yeah, they saw your face.
So you doing this one to see all these.
So so we have so you put zero for everything. Yeah. So let me do this. Who's your children? Who's your child?
My child.
So let's take this to 1, 2, 3, 2, 4. What's your question, Brandon? Brandon, what's your question? So it still remains 0 for all changes in voltage.
Maybe he wanted an alternating source for VGG.
For now, no.
For now, no. But we're just doing both supplies. Right?
Yes.
Yeah.
Okay.
So for all the voltages, it remains 0. What's number right?
So VDD is 10, right? Yeah, VDD at 10.
Yeah.
And as this increases, this should be increasing because.
So what was the value at 10?
Well, the value at 2 is already.
Not gonna go full,
2.5 milliamps.
Yeah, 2. 10 it is.
Well, it's also great length for us.
So
But they had 0 for everything though.
for the second table.
No. Oh, this is the first table. I haven't set up the measurements. Yeah. Okay, so you want us to work on the second table now?
Yeah.
Okay. So second table, increase VGG and document. So now I'm increasing VGG to
Increase it. 1.
did they specify?
So when did you connect the 100K ohm to?
Is this 100K ohm?
Yeah.
To the middle one?
To the middle?
Increase but what are we increasing it to? That's why I'm confused. What are we increasing the value to?
I think we just increase it from 0 because after 1 it starts.
Because it's showing Okay, is it by 0.5 increments? No. What did you guys increase the VGG to 0.5? Like for yes.
Are you trying to find threshold?
Yeah.
Like 1 point. Okay, what's the next step after you did?
You said I think increase VDD 10 volts.
Yeah.
And then increase VGG until there's a current passing. And that's your threshold.
Okay, that makes sense.
Yes, sir. Yes. Please have those.
Okay, so it says increase. So it says increase VDD by increase. Okay, so we've done that. So next step is increase VGG and document the point at the drain. So keeping VDD at 10 volts.
Yeah.
We're gonna keep this at 10 volts. So that's channel 2. Okay, so I've already done that. I'll just take this to 0. Then we're then going to go to channel. Is it channel 1? Increase VGG and document the point that the drain current increases. Okay. So now we're going to do this. So we're gonna increase it slightly. One, two. So increasing the VDD. So we're increasing the VGG until drain current increases. 8, 9. High mode. 10, 11, 12, 13. Linu, at what point did yours begin to increase? What? Are you sure this is connected properly?
It should be. So we have the power source of VGG going to here, going to 100K, going to 50. We have the ground of ammeter, which is going through the resistor, which is going through the 10 VGG, and we have the what do we call it? Why is this going to ground?
Yeah, so it should be so both negatives are meant to go to ground. Both negative ends, am I correct? Based on the schematic, see?
Well,
both are meant to go to the return.
The only thing on the MOSFET that goes to ground is the 100K. No. Wait.
Do you understand what I'm saying? That both negative ends should go to the return. See the diagram. At this point here, negative, VGG and VDD.
Better though, because that's just this and this. We're looking here, and what part of this is going to ground? And I'm saying,
I think both ends are connected to the return. So both the center pin and this are going to the return.
Well, the center pin is this, right? This
yes.
So that's going to the power.
No, see, these two are going to the return.
That makes sense.
Well, that's the schematic. So let's try that and see if it works.
But what's here? Where is this going then?
It's not the ground. I mean, not
Where?
Where is this going? Where's this 100K going?
That's going to the center. Oh, I see your question.
What is our question? For the arrow?
Did you guys connect your 100 to the center pin? Evan, did you connect your 100K to the center pin?
Yes.
Then you connected the. We're done. Yeah, we're done with the first. We're done with the first two steps. Now I want to get our threshold.
Threshold is in the
Our instruments measure it. He gives us steps to measure it. Yes.
The N channel we have is connected to the P channel.
Or what am I? Increase VGG. So.
Yeah. I think in the lab we put.
What do we do now?
Good question.
You say I'm coaching?
Folks, I just want to mention really quick. This is an excellent question. In the lab, I wrote that a MOSFET is actually a 4-terminal device. How many terminals do you see coming out of it, though? 3. The other terminal is on the inside.
Yes.
And
Go
what's the
ahead.
purpose of the other one inside?
If I remember correctly, the substrate and the source are both connected to the return to prevent current from to prevent power from ever flowing.
The substrate is actually connected, depending on whether it's an N channel or a P channel. If it's an N channel, the substrate is actually connected to the most negative terminal.
So the drains
If
at
it's
the
a P
top.
channel, it's connected to the most positive terminal, and it's to prevent forward bias conditions.
So
Exactly.
that's the other one. I thought.
Okay? It just has zero impact upon your lab. This is internal, but that's what that connection means. Thank you.
Yes, sir. Thank you. I learned from the video. So. Huh?
That was in the video?
Yes,
Really? Must have been a really good video I found.
I guess so. Also, the second video, one of the other videos, also named that a pinch off as well.
Oh, really?
Yes. So I think,
I need to write a paper to tell everyone they're wrong.
yeah. So I need to, yeah. I'll show you the video. The second video also says when it's explaining.
Tell me at what point.
Yes.
the second video-
So the first one, I think that was the normal JFET. So the second video was on the MOSFET, and they also said that's also the pinch off as well.
Okay, all right.
So yeah, no problem. So yeah, I don't know what's going on. So these two, I still feel like these two are meant to go to the return. Although that's not the case.
Yeah.
Louis, are you getting? Are you measuring? Yes. No. Yeah, it's not.
She wants to test that.
Okay. So I'm confused why we have the two. I'm confused why we have the two red, these two connected.
So these are both the grounds of both the.
Okay. So this is just the red covering.
Yeah.
Okay. So they're both going to the return. So that's good.
Yeah.
This is connected.
So that's the ammeter going through the resistor.
Is this even plugged in fully? Maybe that's the mistake. If it's plugged in fully. Well, it is plugged in fully now, so I don't know.
Should we put this on the board, make it not a weak link?
Maybe. Or maybe we should just do the voltage thing, like what you said, what you suggested earlier.
We can try that. So this will go from
Because
here.
maybe we're not getting the measurements right. Yeah.
It says.
One at zero. Stop at zero, and you see the other one.
So I have to measure the voltage across now.
But if we have voltage across, it would be a good sign.
Indeed. I'm ready. Yeah. So let's try it so that we don't waste too much time. All right. So now we've reconfigured it to measure voltage.
Yep, just switch up the multimeter.
Yep. So I'm gonna take this up here. Switch this to DC voltage, and that should be good. So now, okay, we're getting 0.001 millivolts. I don't know if that's a good sign. So right now, I should be able to increase this and allow it to change this source one. So
The thing is, 1.6 is basically the.
yeah. Yeah, I don't know what's going on. Dino, can you take a look at our circuits? Yeah, we're not getting. We've stopped measuring current and measuring voltage. So I don't know what's going on.
Or measuring voltage across the resistor.
Yeah. What method are you guys doing? Are you guys measuring current or voltage across?
We're just measuring current, because if you measure voltage across divided by the resistor, it's like 2.
Yeah, we're doing the current, but it wasn't working. So just help us configure our circuit to make sure. Yeah.
So your 1K is connected to the
Middle one.
One can stick to the power source of the VDD.
okay. Your connection looks good. This right here is this is okay, that's there. And
3 is 2.86. 4 is 3.81. 5 is 4.76. 6 is 5.69. 7
Oh, this is for voltage, right?
6.5.
Okay.
So what do you think is wrong?
Well, this is voltage. This is the measuring offset for the multimeter.
Yeah, because I don't know what's wrong, personally.
It looks good. I would just try maybe measuring current instead.
Current instead. That's what we're doing before. All right, let's disconnect and check. All right. So
You said there was a little divot.
So it's back to measuring.
Yeah, you say a 2 and 7,000.
You came from a depth, you came back here, that theory.
A 2 and 7,000.
Bro, imagine seeing that drive. I'll just drive.
Oh yes, it's working now.
Let's make that.
Oh no. Disappointing. All right, switching back.
If you want. Or.
Zero. Output one, output one. Still not working. Oh, mistake. Still not working. I think there's an issue with that circuit.
No.
It's still not working. I don't know why. Yeah, we're measuring current now. So you can take a look.
Power source going through resistor, going through ammeter, going to
Is this your ammeter right here?
this is the power. The ammeter is used to.
Okay.
I'm wondering if it just cuts out the circuit.
So because this is going to the return, this is connected here. This, oh my goodness, this is not. Oh no, it's connected. Okay, I thought it wasn't. It's connected. It's connected. This is connected.
One thing I have to say is this. I don't know. With this setup, since you're measuring, aren't you measuring the amp through here, the current through here?
Yeah.
But it's all in series, so it shouldn't.
Oh, okay. I do not know. I mean, it looks good. That there, that's going out. So. Oh, you have your. Actually,
We have our what?
never mind. Never mind.
Yeah, these two are both the.
Yeah, I do not know. What is your output one?
That's
your,
output one. This output two. I've already set it to 10 already.
Try maybe increasing it.
Okay.
Output two.
All right, I'll increase it. I can increase it to 15. Then go back to output one.
Yeah, I don't know.
So
Oh wait. Yeah, I don't know.
I mean, we can give PGs their own wires. If that's somehow messing up. Thanks for going.
So yeah, I don't know what's going on.
You know what? It should be straightforward.
We're running into the problem, then we started a few different ways.
Yeah, so it's not, we believe it's connected correctly, but we're not getting readings.
Yeah, if we walk you through our logic to see if it's loose, right?
Well, I don't know. Talk to me about what you got.
Okay.
So we have the power source going into the 1K resistor, going through the ammeter, which is going into the.
So this is the black weight of the ammeter.
Yeah.
Here.
This one going to the G side of the MOSFET. Then the gate of the 100K going to the VGG,
Yeah.
And then the other side is just going to ground.
To the
where?
To the
Sorry,
return.
This is what messes people up.
It
Using
goes,
that word,
it goes to the return.
return. Okay, so first, show me where in the circuit you have the ammeter, you said?
It's here. It's across. It's broken between the red.
I think the power supply measures current, right? The power supply will tell you current.
Like we use that in our table.
Hold on. I think the power supply will. The first thing to do, make things as simple as possible.
Yes.
My suggestion is take the ammeter out right now and see if you get any kind of current. What's your VGG set at?
The VGG is set to 2 volts now because we're moving to the second part of the experiment where VDD is 10 and we're increasing the VGG until we find.
Okay, did you find the threshold point?
That's the issue. We're not able to find. We've already passed. People got it at 1.62, so we've already passed and it's at 2 volts and still no current flowing.
Okay.
Yes. So.
Okay. Where's get your digital multimeter?
It's here.
Okay, so what's the first thing you want to do? Use your digital multimeter.
Okay.
And what do you want to measure first?
The voltage across each component.
Yeah, we can try measuring the voltage across.
So grab the multimeter. Go to the circuit.
Okay.
And show me the voltage. Show me the voltage from this point, the reference.
Yes.
To this point.
Okay. So we can do this. So across, sorry, show me where you want me to.
Yeah, sure. We're going to use this point as our reference.
Yes.
And so measure the voltage from this point to this point.
Okay. That should give us 10, I hope. Okay, so at least we know there's an issue. Okay, this cable goes here. It should give us 10 volts. I just hope we've not mixed up.
Yeah, that's right.
Numbers make sense?
Yes, this is just plugged in. Same with the other.
So the numbers are pretty much the same as what we all
Okay. You know.
Because if
I see.
if you're to be in a set,
It's been disconnected the whole time.
even if you
That was a good catch. So that's how the circuit has been working, been disconnected the whole time. So, Professor, I think we found.
the breakdown we need to measure it up somewhere.
That's what that means, yeah. Okay. All right.
Let's test this now.
You should get a picture of that. Yeah. I know, man. It's too beautiful, right?
It is very pretty.
You're gonna have to print it out and put it in your fridge.
I might actually.
I'm so happy. It's like,
Well, it's still not to measure.
Draw
So, how do we push this off?
Reading it all.
This is connected. Here. So this resistor goes in where the VDD is. Connect this in here.
Is y'all vote? Is y'all current change? You're not changing? No, the vote.
Boom.
Yes.
We're getting somewhere. That's close. This looks like the VGG voltage. It's close to 1.89. We're measuring voltage right now. Should this be across the resistor? Or should I put it here?
So this shouldn't be like this. This can't touch.
What?
So the voltage, we have different voltage sources. This can't be plugged in.
So where was this plugged in?
So the resistor needs to go from its own power source
Oh.
to the.
That makes sense. So this was just connected anywhere?
Yeah, just anywhere. And then there's the power source to it.
Okay. At least it started measuring something, so that's a good sign.
You got that, but like, we're still looking at it. Would you mind checking it out real quick? I can look for Kush numbers. That's not really expected. Yeah. Okay. That sounds like one that.
Okay, plug this in here.
I know, or those are the.
Why do I owe you money?
I don't know. Like you. So.
I'm still the cables are very scattered. All right, I'm gonna just switch this off.
Are you getting current readings or no?
We've not started getting current readings. We don't have current readings yet, so we're figuring out what the issue is.
You're looking snazzy.
Hey, thank you. We have we have the music club as playing for the VIP dinner, and I want to go for the inauguration, so that's why I'm hoping we can figure this out quickly. So, all right. Let's set. I feel like we're mixing up cables. I'm not sure, but I want to reorganize all the cables to be sure we aren't. So, sorry, this is our, you can reconnect these. So these are for the measuring, these are the leads to measure. Now we have the first set of output leads. The first set of output leads here. Perfect. First set of output leads. Then we have the second set of output leads here. Okay. So this goes to all the returns go to the same place. That's all right. This goes here to the power supply. Wait a minute. Okay, that makes sense. Yes. Perfecto. Then which one am I missing? Power supply. This, which I hope is connected better now. I still don't think it was connected well. Yeah, so let's try this again. Plugging you in here. And this doesn't have to be connected into anything, it can just be left hanging, the resistor. Then when we do that, we're going to measure across from the return to that makes it. Oh, it makes it up.
Yeah, so now you're learning.
And this will measure from here. Let there be light. I don't know what to do.
Yeah. So set your
Let's detect this power source and put it in its own circuit and see if we can just
When you're looking until it's millions or what?
It should be 0 until you see.
Yeah, these leads don't work.
So what did you do?
I put the power source directly to the multimeter and it's not measuring voltage.
Okay. So we're using the wrong leads again. I think we're meant to use these ones. Or no?
I think that's one thing.
I was right. You made the same mistake for the second time. No, the wrong kind of.
Yeah, that's what
Well, these were the ones you wanted to use.
So yeah, change to. So the power supply cables are good. It's these ones. Yes, they're good. So see what they're using to measure. They're using these ones.
I don't think so, but you can try it.
Yeah. Just because as I was suspicious, because we usually have this plug. Never mind. Let's just see how it goes.
Yeah.
Wait, no, these are power supply. Which cable are you using to measure? Okay, without, never mind. So these are good. Pull out.
We're using the two ideas.
Well, how do we then? I'm confused. Lenny, what are your power supply cables? Point to the main body. Show us that one.
How can you tell?
Yeah, switch. Yeah.
Okay, let's try it out. See what happens.
We've not spoken anything else. Ask Evan. So you see both as power supplies.
So put a smaller distance. Yeah.
And how small should you choose? My belief in things is this. 1, 2, 3, they're about the same. 7, 8, 9, they're about the same. 1 to 10, those are different. Or
No, remove.
Yeah, I'm just trying this one more time. Because
So pull out this top part. What am I even saying?
it's
Pull out. Yeah, pull out this top part. We're going to use it to measure voltage. To measure? No, for power supply. I agree. And you can still connect those heads to it.
No, threshold.
So now,
Or yeah, you can use.
you can get it close.
Yeah, to be safe. Okay. So this is as good too.
Why don't we just measure if this is gonna work with the multimeter?
Yeah.
So,
Yes, I haven't measured any. Yes. We haven't measured anything yet for that.
finally.
So now let's remember this. These cables are good for measuring. Never use these with. So what did we switch?
We got rid of
Those two cables.
Yeah. Which is what we're using for the other one, so maybe those are going to be a problem. Here, why don't we measure this voltage as well?
Yeah. Yeah, just clip it to these.
Where is the ground for this?
This is the ground. This is the return. I just broke. No measurements.
So let's do the
Oh. This is perplexing.
Well, the first one.
So yeah, no measurements.
Huh. So we just need to avoid those ones.
So what? I feel like someone sabotaged, like mixed up all our cables. So this doesn't do any measurements.
Do you want these?
What do you use these for? Okay, we have to pack cables. Unplug those.
Yeah. Do you know what table two is? Do we have to record the waveform?
Just record the waveform.
Alright, thank you.
Yep.
Are you guys done exercise two?
Yeah, we're gonna do it.
Okay. Yeah.
And it says, yeah, it's like,
Oh.
Okay. Are we good? So we have these two cables.
Can I borrow the one second? I forgot to take a picture.
No, that's all right. So yeah, let's replug this in. So we use this for measuring.
Let's get the other power
Working, yeah. Man, this is big. You may thank you. Let's switch the levels. All right. So plug this in. Plug this to power.
Also isn't working.
Thanks for correcting us.
Oh wait, that's the wrong ground.
Okay. Perfect. It's working. It's working.
Yeah.
All right. You want us to look into your third eye? That's cool. That's cool. That's smart. All right. So now we can work. So we know this works. So switch this off.
My third eye, I don't agree with this lab. Usually we focus on the lab. I focus on the lab. We'll fix it all. We have our function paper with this.
Okay. So this is going to the VGG. VGG.
Remember we did
So I'm sure this is good. Then this is, you already plug this in and plug this in. So this will be for the VDD. So you can plug in the resistor.
So
We can plug this into the same spots. Yeah.
Yeah, they opened the gate today.
no, this
Just
is
for today?
this is
I passed by I think
Catch,
that's way earlier.
plug in
Hey, not really, like, that gate is still the most convenient for parking.
to the return.
How's the park here? You go to that gate and take that little road.
Okay.
measuring voltage
Voltage.
across
Oh,
the resistor.
turn around.
Let's do that now. So we're going to put this. So this should be. This got broken.
It depends on where you come from, right? If you're
I'm coming through there, yeah, like,
Yeah, if you're coming this way, if you just turn in there, you would be in the parking lot before you'd be at the gate.
So you
Oh no! Instead of going all the way down River, going to all the way down.
3/4 miles that way, and you gotta weave your way back.
Oh yeah.
Come on. Come on.
We could go down. We could also go lead right there too.
so switch this to
Yeah.
display limit
You get hit by it. I get hit by it.
Output
You go that way, you hit speed bumps.
0, output 2.
McNichols down to, whatever that is.
175.
Yeah,
175.
Yeah.
Okay, 2.5. 25.
Need 40 hertz.
10.
10 volts for B.
Switch on. I think we're measuring something. So this is display, this output 2. So that means it needs more current than what we're feeding it. So I want to increase this now to.
I thought if anything, you guys are still using that tiny one. You can just roll with any other thing.
The tiny one is lit.
Evan, no, it's not.
It's so. Did you take our hammer?
No, I didn't get their hammer. My hammer.
Perfect. So you can see it's balanced now.
Yeah.
Then voltage.
I'm not trying to test.
Perfect. Then okay. So now we can proceed with all our measurements. So now we're meant to measure the current across. So let's start with that. So we'll disconnect this. Switch this up.
I opened my box with the waveform generator.
So
I think this is yours. I think it is. This one. Yeah. We've got everything else.
Well, that belongs to university, it's not mine, but belongs to
Okay. I guess I forgot, like, the day that we had to borrow this one, was probably the day where I left this stuff at home, remember that? Yeah. So, now you have two.
Yeah.
Back then, huh?
You'll never have too many more.
That's fair, maybe on this one, that's
Right?
switch this to current.
I heard people asking about it, so.
No, no one's asking if it was 39.
No, yeah, it wasn't turning on.
Then it's already connected to the return. So I should switch this on.
Evan,
Yeah.
do you get saturation at 3?
Oh, I'm measuring.
You get saturation at 4. But did your current barely ever change after 3 volts?
So
I mean, it's a little bit, but.
Well, like,
the current we're measuring now is across what? Increase
Yeah, I mean, you'll see it when you grab it, right? But yeah, it didn't change. Like, no, so like when you're putting in, it's like what you're at first.
after first.
Yeah, yeah. When you add UTG is your actual.
Yeah, no, it's 3 volts. It's saturation.
I have 3 volts.
You get saturation at 3 volts. So it stopped changing.
No, it's not saturation. No, it changes the whole time. There's not a lot.
Okay, a few microvolts is not changing.
It is when your base is 3 microvolts.
Should we go through millivolts?
Yeah, ours
No.
0.07 to
No,
0.0. Sorry. Yeah. Yeah, it went from 0.07.
All right. So let's restart the experiment. So now measuring the current across.
Cluster is going on OSE.
Yeah.
Andres.
Okay.
We have the power source going to the resistor going into the
Ammeter.
ammeter, and then the output should be going into the drain.
Yeah, you like it?
Should be across the drain.
Yeah, well, the ammeter should just be in series, right? So it goes from the resistor to the drain.
I'll wait for.
Okay.
Yeah.
It was like week 1.
And then the 100K to the gate, and then the last one gets to ground.
All right. So I'm gonna repeat procedure 1. So now that that's connected, 1.
What is happening? So we put that aside. So yes, if you measure lower, we're gonna measure across our thing.
1. So see the milliamps we have. We have 0.199
Yeah, and you
milliamps.
measure across the MOSFET, right? Okay. Yeah. We're not
We
getting
have 0.1989 milliamps.
For 0 volts?
Yes, 0 volts.
For both of them? For,
0 and 10.
you have 10 for the VDD?
Oh, give me a second. So no, we're starting from 1.2. So I set VGG to 0. See, 0.
Wait, the second one's V.
We're starting from the beginning. So
Wait, yeah, I know, but
the second one is VDD.
Yeah.
First one is VGG.
yes, the first one's V0.
Yes, 0. Now output 2 is 1.
Okay, so
So at 0 it was 0. Let me be sure. So 0.1986 milliamps.
okay, and 2.
Could you check your circuit simulator to see that's a similar thing you're getting?
Okay, so if we have this at
0.
the VDD,
Yes.
then VGG shall also be 0.
Now set that to set this
0, 0, of course.
Yeah.
And then
set this to 1. Check how much.
Yeah,
That's close. No,
No.
nano.
Well, it's 0.2 milli.
Yes. Multiplied by 10. Yeah, this is correct. This is nano because this is 0.198 milliamps times 10 to negative 3, making nanoamps.
I don't know about the conversion, but I believe you if it's right.
You say multiply that by 10 to negative 3.
Multiply this by 10 to the negative 3?
Yes. Negative 3.
I mean, it wasn't turning on because of that. That's the fun part.
Yeah, but that's going to be amps.
No.
Yeah, no, this doesn't work. If we want it to be nano, we'd have to multiply it by 10 to the 3. So it'd be 198 nano
I see.
amps. Wait, that's what it is. It's 180. And we have 198. So we're right.
So go back.
It's 180
Nanoamps.
nanoamps.
And now we have 198.
Yeah.
Yeah, because we're converting to.
Yeah, but we don't need to do that. It's just to make sure we have it right.
Okay. All right.
We at least know it's right.
Yeah. So let's continue. So I'm going to move this to 0.1. So I'm going to move this to 2. 1.0064 milliamps. I'm sorry, could you check again? Just want to make sure. 2.
191, 191. No.
What was the last column for the 1 volt?
UGS threshold.
Oh,
threshold
This is a 9.
This is up to 2 you're changing, right?
Yeah.
Yeah.
This 1 milliamp.
Measure ID.
I'm pretty sure if you make this even, yeah, it's
Lino, did you guys have, for the first part of the experiment, do you have all zeros or milliamps? All zeros? All right, so back to square one. Let's go back.
So did I plug in everything right? That's
Measure the circuit's drain current.
This is your column of current at threshold. This is your column of current at threshold plus 1/2.
Exactly one word, but keeping VDS.
You're keeping
VDS
right.
So for each increment,
yeah.
VGG, that's close multiple currents. So
Yeah.
this one,
Now that I look at it, this is, I guess in theory, it should have.
This is its own.
Yeah, in theory, it should have, whatever, drop. You're measuring drain current under at threshold.
That takes
drain current at 10 volts. At threshold. 10 volts.
So if I increase this to
Keep 10 volts. I mean, it's the threshold plus over there. Measure the current. Threshold plus another 10 volts.
Yeah.
Measure the current.
Yeah, I understand that. I'm saying
Let's-
one table.
I still think we might have everything good. Let's try testing to measure the threshold voltage. If that's good, then because this might still be negligible, this really helps. So let's scroll down. Really scroll down. Let's see the steps to do the threshold voltage. Increase VGG and increase VGG and document the point, keeping VDD at 10 volts.
Yeah, that's fine, thank you.
I'm confused with the threshold part.
I just have a quick.
Like.
You wanna look at the drain current,
You
you wanna determine the threshold by looking at the drain current.
So, so we can find the threshold 2 volts.
Okay,
So what do you mean at the top? It was like the threshold plus 0.5.
then take a measure. So VDS 10 volts.
Yeah.
You find the threshold.
Yeah.
Increase the threshold, increase the gate voltage by half a volt.
Okay.
One.
Hold VDS 10. Increase by half a volt, measure the drain current.
Oh, do you want me to do this?
Increase by half a volt.
Sure.
Measure the drain current.
So set VDD to 10 and that's to 1 and that's to 0.
Each time what? Each time you increase the gate voltage, you have to measure VDS.
So at 1,
Yes.
So you don't.
No, you don't,
It's just that.
just hold it at 10.
Otherwise, keep up definitely up.
Yes.
Increase VDD and document the point of drain current increases. Keep VDD at.
Well, okay, all right, you guys did it. Okay, great. Well, some of you would never get out of here. No.
Yeah, well, so I do have a question on exercise too. You just want pictures of the waveform, or do you want us to have like table values, or will the pictures suffice?
Well, what did I say?
It just says include the waveforms. It says.
Okay, so we have,
Does that mean, like?
okay, so pay.
Maybe, you know what, I guess I should have said to obtain a time domain visual representation. I'm looking for That's on.
Like, just picture like we want like E to P or like.
Whatever you think, would let me know that you don't you. Which could be
These ones.
a long time.
Yeah, it might be a while.
Okay.
Might be holding out for a while now. We'll see.
So we are.
Remember what resource can be your friend in all this? That's this thing called simulation.
They call it lab professor.
It's what?
It's called lab professor.
Simulation, right? That can be your friend. If it doesn't work in simulation, it won't work in real life. If it does work in simulation, it may work in real life. Right?
Yeah.
You're right.
Yeah, one is our BD. One is our BD, and then our BD. The 2 is 2 volts, right?
Well, how do we set the
2 volt threshold? So we have to, it's confused, there's an error of that. Are we reacting that? You start getting. Yeah.
Yeah.
So, because you're new,
Yeah.
not from my mind and how you did it, because I'm confused and I don't know how to do it.
So you have VDD 0 to 10. You have IV.
When you're measuring the current across the drain, how did you break? Come see, I think our stuff is set up correctly. So this is the drain. So
You could literally just say add.
So this is the power source.
VDD equals 10, and then just do VGS on 1.
this is connected to the ammeter.
No.
Do I connect the return? Like, do I connect the black
But if
lead
you guys not gonna make sense,
here?
you only have 1 point.
where's here?
You guys not gonna look.
Remember, this will be
You only have
connected
one
here.
value.
But this time
I think so. What I did is I just connected to here.
you connected this to here.
Yeah. I know I did. So I did. This is your.
That's the resistor.
So this is for the ammeter, right?
Yes.
So I did this.
Okay.
I
So you have a threshold to.
put this right here,
Okay.
and then I put that right there.
Okay.
There,
Okay.
and then
Then you connected this back here
I connected to the first wire.
to the first.
MOSFET.
Thank you.
Threshold.
I think that would work.
Okay.
I assume so.
Okay.
Does it work?
We're about to find out. So if I set this back,
So what is that two?
So
That two is your ID at zero.
So this would be zero.
Well, apparently you don't need that. You only need it at VD equals 10. This is.
Well, I'm saying.
What is your table?
Right, everything. All we have to do.
VDD goes 0 to 10.
Yeah.
Yeah. VGS, it starts at 0. VDD is at 0. Threshold.
what is the meaning
Threshold
of
plus
this?
1. Threshold plus 1. Threshold plus 1. Until VGG equals 5.
It doesn't make sense. Ours is reading values
Okay,
in
so I
the
have-
order of milliamps.
Milliamps? Yeah. The time has come. Yeah. Did you turn it on?
Did you have no like for the first part? Did you have 0?
Oh, yeah. The first part is 0.
So I'm having milliamps here.
How many milliamps do you have?
Oh, that's a lot.
Well, 0.2, but
Like this is
What is channel 1?
Output 2. Output 2.
output 2 is the VDD.
VDD.
This one.
And channel 2 is the.
I see output 1.
Wait, that's the.
What?
Makes sense, 'cause channel 1 is DC.
So ours.
I don't know. It shouldn't. Output 1 should go to power, which goes to here.
Yeah.
And then where's this one? This one.
No, just say it.
Right there. I don't know. That's weird.
to go into this.
This is the power lead from the output 2 to here. Someone just said that's wrong.
I don't know. Yeah, that's weird.
The voltage of this DC supply.
Well, I switched it to what he said, how he did his. That's why.
Because you got current coming out from here, which is going to the ammeter, coming to the
Yeah.
here, which is going to there.
And you know the same readings as when we did it there before.
Yeah, it doesn't make sense to me.
Output 2. Yeah, I don't know. Output 2. So output
That's
1.
VDD. So once I like it begins to read current.
Yeah, that's really weird.
Was your gate connected? How was?
Is yours switch? I think yours is. I don't know. Okay, so output 1. For some reason, it's like doing like the characteristics of his own switch. Like if you change this, it doesn't affect current. But let's say this. Let me see. Go 5.
Because it's in enhancement mode. If VGG is 0.
Yeah, I don't know. It's like it's switched, but it's not switched. You get what I'm saying?
Okay.
I don't know why though. Because it looks like you have everything wired like good.
How about the middle one? Was it connected? Because I'm looking at the diagram. It looks like the gate was also connected to the return as well. Was it in yours?
No, I just had
Just had the just
yeah. Maybe try
rebuild. Yeah, I think I might just rebuild.
yeah, maybe like what I would do is let me I'll put this off real quick. Okay. What I would do maybe is just
So I did that one right here.
here's
Yes. The next. This right
just-
here is this.
like I would use what I did is I just went simple. So I didn't
This thing is-
How about?
yeah, looks good. Like I didn't use all these like wires and stuff.
Yeah.
So you got
I know we had to grab. So 1.5, right? I thought we had.
you see it? I think I see it.
It may not. It may just be bad.
I think it's bad. But maybe personally, I would do is I would just simplify it. Don't use like all of these. Just like for example, if you don't mind.
Yeah, that's all right. Yeah, I'm gonna
Here.
so that's the measuring, that's the ammeter.
Boom, and then this is what I did. It comes out right here.
So this is the ammeter, you know that, right?
Yeah.
Okay.
So it comes out right here.
You see that? And then what region?
I would have this connected to here,
Okay.
and then I'll have these leads connected to here.
What operating region?
I have these connected to here, and then the power is connected to these two things. That's how I would do it. That's what I did, and it worked for me.
Okay. All right. Thank you. Let's test it and see if it works.
If you have other here, oh yeah, you do.
Okay.
They don't-
No. It's the cable itself. Let's test to.
I mean, that's what I did. It worked for us.
There's actually another easier way for simulation to tell what you're in. You just bring your mouse down here, and it doesn't turn out. Well, on my screen here, it tells what region it's in. It says saturation. But anyways, that makes perfect sense, doesn't it? Yes.
How much did it cost me to create that model?
A few moments of your time.
It's like 2 minutes.
That's it.
Okay. I was gonna say, never mind, these, it's not polite to ask for. Your
Sure, it's polite.
Would you have been asked, like, how much do you make at the university, how much time do you take?
That's exactly right. That's exactly right. That's an excellent question. That's what I think our guest speaker said last week, right?
He said, use the oscilloscope to multiply the form.
Yeah, time is money.
The function.
You're right.
Let's see what happens. Oh, from the function generator. Could I see your conductance and resistance value? Sorry.
It's all good because I'm looking at that shit. I can't really find it. So I just want to double check.
Yeah, I think conductance wasn't on the data sheet, right? But it was 1 over RDS.
I just did the VGS, or IDS, not the VGS.
No, there's the forward transconductance. They're like in forward bias or something? You cannot put a MOSFET in forward bias.
So where's the forward? I never had an ID go for it. My ID was like max like 9.
What's easier?
So I don't know if that.
There's this thing that I did for you, and it's for,
I can't grab that.
What was your threshold voltage?
It's
it's 2.1.
We had a big vote.
Don't feel that. Go for the hammer, I'm surprised. Oh, 7,000. Okay, so that's all. When you were looking at the threshold, it's in at 7,000. Okay, so go down to where's the threshold? Oh, it shows you the minimum, typical, maximum.
I can see it's at certain values. What did you?
Oh, yeah, for the 7,000. I just noticed our data sheet was for like multiple MOSFETs at the same time.
Yeah, and it's got the numbers.
Yeah.
So. These values are the same for the two line. So this is 100,
You got 3 for max.
well, yeah, and in milliseconds. Did you guys take that?
No, we didn't do it yet. We're gonna have a lot of pictures. We're about to be there though.
Did you get it to work?
Okay.
I'm just rebuilding it. Yeah, we'll figure it out. We'll figure it out. Thank you, though. You're good.
Yeah. I gotta put my glasses on to find my glasses.
That's a bit of a problem.
That's why I wear contacts. So yeah, contacts, but I can find my glasses.
My mom is basically blind. I passed here with her glasses on. And we were at a friend's house, cabin, just decided to jump in the water, she tried to take them off. Lost them in the water. The dads went out there with brakes. Found them. Not to mention the fact that they always figured out classes and days. That was the week.
Oh, yeah. Yeah.
There's an issue somewhere. It's off and it's measuring current.
Okay. Yeah. Yeah.
You see that? I think this is bad.
Yep.
Rather than the subscription one to the item gets up to 400.
Yep.
There's no logical reason why it should be measuring.
I mean, it always will fluctuate, but
Like it's see now. See, it's off. It's not measuring anything. When we plug this in, it should be 0. We've used this many times and this never happens.
What is this measure? That's the signal from the AC generator.
Why are they measuring milli? It's not making sense why they are measuring.
I'm gonna say it's millimoles.
There's something like there's no reason why, because this has already messed up, because this is already milliamps 0.02. Then if you now measure what this is flowing through, it adds up. So I don't know why this is measuring the value.
that's a really small.
It should be 0.
Yeah, so-
Remember, this is already in milliamps.
Yes.
Then if you measure what is flowing through here to add up to this,
So that's 5 nanoamps.
This doesn't seem right.
Okay, between 3 and 5 nanoamps.
okay, let's test.
I don't think it's-
Okay, I want to measure the voltage across, so let me do that. Oh, never mind. I know why it's measuring.
BTS.
It was it's my error. I was measuring voltage and I put it in milliamps. That's all right. So that's good. 0 millivolts.
ID? Your ID should be pretty close to 100 your
1.
like, say
So this is
your
measuring the right
voltage
thing. Should be 5 measuring.
Your ID should be like 2 milliamps. Close.
Then if I wanted to measure voltage across this.
Hold on, I'm fairly confident.
I'm seeing your videos.
2.
Okay.
Okay, so measuring voltage is correct. I think we should just measure the voltage.
Yeah.
So set up in the Excel, just do, so yeah,
I can
do
jump
voltage, yeah. So do voltage divided by,
Okay, my readings are maybe for better.
divided by, is it 1K? So that would be this value. Where's this? Yeah, this should be connected here.
I said, Evan, we're going to do 5 volts for the BGS? Or BGG?
Times 10 to, times 1000.
I don't know.
Yeah.
I mean, this is it. I want to look at this late about what
All right, so now drag that down. So all we have to do is just change the voltage value for each one.
Tell me something.
Is this for the right? VDS. Oh, never mind. Okay, VDS ID. Okay, so this is the ID current.
What's that?
Does the ID represent current?
Yeah.
Okay, so the current of the VDS. All right, that's all right. Okay, so I'm sorry. Let's start from here again. So set VDD
So
channel 1 0.
let's at least figure this straight.
So
the power source VDD going in.
yeah, this is measuring voltage
Uh,
across, and the return is here.
let's at least put this in same spots so it can be consistent. There needs to be something actually going from there to ground.
So the one across the way from there was good, because it was going from. Right, and that was fine. Yeah.
So let me increase this back to 5. It should give us 5
Channel 1.
or 4.
Channel 1.
So I don't think this is the best place to put it. See,
No, I think the place you have to put it.
see the value is giving us at output. So it should give us 4 volts across.
4 volts is the entire circuit. We're measuring across the resistor.
So from.
Oh, you're right.
I mean, what I was trying to do is from here to the.
So run with this number, 2.876.
So you see the supply.
Okay, give me a second.
To.
So this is
You
the.
had points where you want.
You're right. Okay, all right. I'm sorry. That was me. So I'm measuring the voltage across. Okay. So yeah, that's voltage value. Yeah, divided by. So yeah, 2.876. That's about 1.
So it's to the return.
And this should still
So our return pin is fine.
So that's about what? 1 milliamp.
it's as if it's the this is in milliamps already because it's voltage divided by kilo ohms.
Well, are you sure? This is in. Double click on this. Doesn't give us accurately amps because this is exactly ohms.
So
Yeah, that makes sense.
Voltage
oh,
divided.
you're right. So it's about
So divide that.
amps,
Yeah. So multiply.
multiply it by 10 to the third.
Yeah.
It was connected.
I'll put brackets.
Oh, yeah, so you were forcing.
Don't press into put bracket behind. Okay. So that's 2.87 milliamps.
Yep. And this is where it's supposed to be 0.
It's not making sense to me at all.
So if this is 0, this is 1. It's supposed to be.
Everybody has 0 for everything. It's not making sense to me. Where's my calculator?
Why? Let's think about this. I mean, you could remember
Voltage divided by.
and have the sinusoid. So
That's not.
of course, we're reading that. That's between
4 divided by everything series. 4
exactly.
divided by.
It's like adding because our DVD is constant. Yeah. Right? It's pictured like this, right? Our VGG is going from 0. Our VGG is going from 0 to 10, right? So if you look, once it gets past like here, current really changes. So when you get to the divided point between 3 and 10, it's going to be the same.
Yeah, I didn't
have
touch
to this is the same. Same voltage from the drain. Right? So that doesn't make sense. It also makes sense that it's wide too. Right? Yeah. It's like the two waves are. Yeah, but imagine this like 0.098, 9.7, 9.7, all the way to 10. Right? And basically we're doing is taking that as 1. Right? The sine wave is 1.
Right.
So yeah, it makes sense because from 3 to 10, you got basically the same current.
Well,
So That's what I mean. So it's going to spend way more time high below, which is in fact, we have one, 3. We're not write it down somewhere.
I'm like the very first one. You have all.
Say,
No, I mean like the first part is like the first 2 steps. What VGS
let me first,
I don't know what's wrong with that cycle.
Because the BGS is like a switch.
Yeah, I know. We try to fix it.
Reduce
it. Then we have to.
You keep getting the reading because.
Yes. We rebuilt it like 10 million times.
I think it's DC.
So
if you look at,
Let's see.
So yeah, I think the circuit, you can look at it. So now it's in the current measuring
it's
mode.
going from,
So this,
from 0.
so just take a look at
From 0 all the
this
way-
position, right?
Well, how are you measuring the current?
Just across, we broke the circuit here.
It's going from 0.
You broke it here.
Yes.
So that's
All the
out.
way to 10.
Let's connect to that. Wait.
But, you know.
And then this jumps it.
I mean,
To
it's
this
kind
is
of
the source.
because
What is this?
thing is,
We have the circuit open.
so what's happening is that.
The circuit.
So this is what is measuring. These are leads to measure. These are all the power. We have output 1
So
and we have output 2 here. This lead and this lead, output 2.
Okay. So the 1,000 ohm,
Yes.
the leads across this.
Yes.
What does the 1,000 ohm connect to? VDS?
Yes.
Okay, so this is VDS.
How did you measure your
Which-
current?
My current, I went through.
Where did you break off?
Yeah.
Okay.
Yeah, so I did that, but I did through the desktop. Okay, and then what my problem was is my sources were mixed. I mixed my sources up. So
I'm sure our sources are correct. This cable goes to VDS. This one goes to
VG.
VGS.
So what is VGS?
So VGS right now it should be, it's 1.
It's 1. Why you have it at 1?
Sorry, it's 0. I mean.
So it should be at 0. And then, so when you increase VDS
By 1. Look.
by 1, you get a reading.
Yes.
That's interesting. Let me see.
Can I switch my?
It's either this is broken or your circuit's messed up. Do you want to swap
Transistors? Because we reduce like. And the voltage sharing across works.
Wait, what's it question? What determines, what does that line tell me?
That line right there says the magnitude of about.
But this position holds.
Okay? When we see 10 volts, okay? When we see 10 volts. So when would you see 10 volts? During the switch. The switch is when it's closed. No, open. That's sneaky. See? That is sneaky. Because that's the open circuit.
Yeah. So how should I place it then? Because at this point I'm confused.
Well, center is
Center is here. So do I place it this way or the other way?
put in.
Like this?
Yeah, the top. I mean, the leftmost is the source.
With this position here?
He has it right there. So the leftmost is the source. So is this the source?
Yes.
Okay.
No, that's the drain.
That's the drain and flip it.
Sorry, it's closed. Yeah. No voltage. Yeah. Well, close to being on voltage divider, right?
Is that good?
Yes.
So looking at the flat side, this is the source. I think that was your problem.
When it's closed, isn't it?
So this is gate. This.
Hold on, you have something sharp I can point to? Can you use this?
So when that
Sure.
MOSFET is on.
So yeah, this is
Full MOSFET is
looking
on.
at that. The leftmost is the source.
Okay.
Which means this is the source.
Wait. Oh.
MOSFET is on.
Right?
Yeah, no, that's the source.
So in this diagram, what are we connecting what to?
This is the source.
So I should connect. So okay.
That's the right. That's the start.
Source,
Okay, good.
drain,
Drain,
gate.
gate. So
This is the gate.
okay,
This is the drain.
okay.
So
It works. You did. That was a mistake, I think.
What, it was just backwards?
Yes.
Okay.
Wait, just wait. Let me switch it now.
So flat side is facing that way.
I think our transistor is bad.
It might be. Maybe you're just bad. Oh, yeah, I think your transistor is busted.
Are you kidding me? We've repeated this. Wait a minute again. God bless you. Thank you.
Did you guys get it?
It's been damaged. Are you going? I need you. I have to speak to the other, but the other stuff are relatively easy. Okay, I hope. All right.
Are you doing the AC one or no?
No, we've been stuck on the first part. Professor, please.
Beginning anchor.
I switched with Brandon because we reviewed the circuit 10 million times, tested.
10 million? Because you had the transistor. Throw it away. Did you burn the transistor?
I don't know what that is. All I know is that it doesn't work anymore. Put it through the way, please. And I'll speed through the rest. So, the transistor we've been using for the past 1 hour, 21 minutes has been damaged. Don't know when it was, gotten a new one. So I hope this works better now.
You see what you did?
One. So now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put 0, 0 for everything. Thank you. Now, next step, increase VG, increase VGG, increase by 1 volt of temperature drain current.
Okay. We need to have VDD at 10 volts.
Okay. All right, let's go this way. Output 2, 1, 0. Output 1, 1.
Yeah, 1 year left.
I'm not gonna notice. I'm gonna drop weights and fall off the monster.
So, Brandon.
That's still
Oh, sorry, Brandon. When you're measuring your threshold voltage, when you set VG, what is your threshold voltage?
No, we don't know.
So when you were at 1, did you have like 0 point something milliamps? Like I have 0.044 milliamps at 1. Or do you have 0?
I mean, you really, as soon as you start seeing changes,
I have it at 1.
there's just.
Yeah. You know what? I'm sorry.
I think if that worked.
Our friends,
Next week.
all right, so at 1, I want to switch. Actually, could you check this sheet? What it is at 1? So that is 10. 1,
271 nano. You get 451 nano. Same idea.
451 nano. Okay. I just want to test this, make sure. Because I mistakenly moved at first to 20 instead of to 10. So I want to make sure that this isn't damaged before I proceed further.
Why was yours a square? They should know. Why was yours a square? Because of the way that was our VPS.
I knew it.
Are you raising it across?
I knew it. I knew it. I knew it.
You got us.
I knew it. I damaged it again. I knew it. I knew it.
We do. So you're supposed to measure the function generator and
So,
so you need to record and well, now where did it break? Function.
yep. So the threshold voltage, is it immediately there's a change? Because right now it just changed from 0.000000 to 0.00001 at 1.5.
Are you above the threshold? So we were using like a multimeter and we had it set to milli. So we might have seen it like a tad bit late, but ours happened around time.
So like mine, this is very small current, but if I take this down to 4, gone. I take it to 5, 6, I start seeing more.
Yeah, I mean, go to 2 real quick. I just want to see what it shows. About 0.1 milli. Yeah. So because we had our thing set to milli, we didn't see it until it was about there.
Okay, thank you.
Yeah.
All right, Professor. So for the threshold voltage, right now, the multimeter is set to milliamps at 1.4 volts. When the VGS is 1.4, the VGS is constant, and I'm measuring current. When I move it to 1.5, it's 0.00. That's when I see that first. Should I now use 1.5? Should I leave it? Should I use so how much? Okay, so let's increase this to 2.
This is our drain right here. What's your VDD set?
You're done with the MOSFET.
Let's pick 1 point. Let's use 1.7. At 1.7, it's 0.0029 milliamps. Do you want to measure the 1.6? At 1.6, it is 0.0007 milliamps. Yep, perfect. Now, so increase VG in 1.5 and range the drain current at each voltage up to. Okay.
So now it should be 2.1.
So I should go to increase VG in half volt increase. I take it to 1.2. Because right now increase VG and document keeping VD at 10. Increasing VG. So Evan, could you please come? So what does this step want me to do?
So let me get my.
Does it matter what your VDD is?
You know what he is.
So what we did is we at each VGG, right? So you have your V threshold, right? Yeah. So you'd set your VG to V threshold, and then we measured 0 to 10 all the currents, right? Then we increase VGG by 0.5, and we measure 0 to 10 all the currents.
So
But he said you don't need all these middle measurements. So everything I'm highlighting right now, you guys don't technically need.
so what do we need?
So what
We
you
need
need
at
is
10.
Yeah, set VDD to 10, increase your threshold by 0.5, and then measure current. And you just do that until VGG equals 5.
So increase my threshold voltage by.
Increase your VGG by plus 0.5 of the threshold. So
Okay.
if your threshold is 2, you're going to set your VGG to 0, 2, 2.5, 3, 3.5, 4, 4.5.
Okay. Can I see your table again?
Yeah.
So what was your first? So this was at 0.
Yeah. So this column VGG 0 to 10. This is like the
Yes.
x-axis.
Then you had VG equals to 0. Okay,
Yeah.
perfect. Thank you so much.
Yep.
So
And by the way, you program we're using of
0.
why is it that hard?
Do you get it now? So this is the first one we did. Now we're doing 1.7, then threshold plus 0.5 plus this plus that until VGG is equals 5. And we don't have to do it multiple times. We just do it at VGG equals to 10.
Okay, wait. So let's move this over since we're not going to be doing it for those. We're going to be doing it for
VDD equals to 10. So you can put, I guess you can put VDD here and put 10. Yeah, equals to 10. Perfect. So I guess VD was also equal to 10 for all these ones as well. So then I was thinking of what else was I thinking of?
So now we do this for
Yes. So now we're doing this at 1 point. So now at 1.7 we know what the value is. This output 1. So now at 1.7 you can just copy this value and put it there. Yes. Now, so yes. So now we go to 2.2. 1.0412. Then at 2.7. 9.7957. Then
Slide wasn't long enough. You got time to walk around.
so you need to do more. So yeah, we need more. So this will be at 3.2. Keep increasing it until VG is equal to 5 minutes. Yeah. Okay, I think we could reorder it. Yeah. So VGG 3.2. Yeah, so just add more. So we need 3.7, then 4.2.
I'm trying to estimate the labs, more time consuming.
4.2, then 4.7. So now that's like my last. So I keep increasing by 0.5. I'm at 4.7. So that just stop at 4.7. Or should I still do? Yeah, just move at 5. Yeah, just move at 5. Thank you so much.
You guys going away, man?
All right.
We're just going away. Okay, see you.
3.2, 9.8559 milliamps. Professor, will you believe that the other transistor was also bad?
You believe the other transistor what?
The other transistor was also bad.
Two in a row?
Yes. Maybe I did something wrong.
Maybe.
I'm sorry.
Maybe.
But
Nobody else had a problem.
I'm sorry for the waste of transistors. Yes.
If we go through a lab and nothing ever gets broken, we haven't learned.
True.
Right?
Yeah. Okay. So that's at 3. So now it goes 3.7. 9.8652. 9.8692. 9.8713. 9.8726. Now construct a table showing ID for each. Is that what we just did?
Yeah. No. So kind of. But we haven't done any combinations of VDG.
Okay, let me quickly ask you.
Ideally, I would prefer to have 35.
So, it survives by somehow something else. Someone else. John, read your
As of now, as of now, I didn't teach.
See, but I'm
So, the stage, step 1.5, you want us to measure the change the step 1.6 for each dimension of VDG. So that's basically what we've done at 1.5.
Yeah.
What we've done is correct. 1.7 plot the output characteristics of VDS versus ID and the transfer characteristics of VGS. So we have VGS and we have ID. Plot the output characteristics of VDS versus ID. Output. How do we measure them? Let's switch this off. So at a particular VGS, we will measure the ID, we will increase So step 1.7 says what's the output characteristics. So now we have the VGG values and we have VGG and ID. So VDS, what do you use 10 volts for?
Yeah.
So how
Okay, so go VDS versus ID.
yes.
So at different VGS.
Okay.
What is check?
Makes sense?
So we should measure
So VDS is always going to be
10. Yes.
Makes sense.
versus VDS versus ID or whatever, VDS divided by ID. Or different VGS.
So basically we have one constant there. So because I was confused because I felt like we had two separate ones. Just add everything.
Yeah. You use this at 10.
At 10.
And then whatever these values came out.
And graph VGS.
And then do VGS.
Do you see my
Yeah, okay, so we're gonna change. So we're gonna have VDS
yes.
versus, okay, VDS versus
ID.
ID, whatever that, VDS or whatever, ID. Or whatever, VDS, ID, something.
Yes.
Then you're gonna have the different gate voltages, right?
Okay.
Then do VGS and ID. VGS, ID, for the different.
So this I understand because we already have this.
That's all right here.
Yeah, so that's my question is this VDS. VDS is supposed to go going to remain as 10.
This is talking about the mean.
Oh, it is also because the graph is going to be a vertical line. So that's what you have. So VDS 10 is going to be minus. Oh, so it's going to be a straight vertical line.
Yeah.
All right. So for number 7, it's gonna be a straight line, but it's gonna be a VDS 10 and all the ID values. You understand? So it'll be a vertical line. While VDS versus ID will be a normal curve that we'll see. Then calculate GM, RDS, and compare your values shown in the data sheet on the transistor. I feel like we should do that now in case we make any mistakes.
It's just calculation. Let's just do what we have to love because I need to go at 2:40.
All right. I just hope, we've been having issues. I just hope all our values are correct. But that's all right. While I set this up, could you graph the VG? Replace the DC source VGG with the 40 hertz. So that will be switched off. Replace the DC source VGG with the 40 hertz 10 volts peak to peak signal. So just this one. Your
to catch the saxophone another time. Whenever you call right with the call
I could play for you right now. I wonder if Professor Steph has. Ask him.
You always said, Professor Stephen.
Yeah.
Would you mind saxophone music?
With what?
Would you mind saxophone music?
Saxophone music.
He plays.
In person.
Really?
Right now. Because it's his birthday.
Try it out.
That belongs to all of you, right?
Go ahead.
Right?
Let's start here.
I don't know. Ask them what they're doing. I don't know what they're doing. Ask them. Okay.
You can set it up.
I'll send my schedule and everything today.
Thank you.
Hey, he's the best of Oh, and email is easy, I think. The one with the like this. And I'll start working on
Yeah, I heard that. What else?
I'm on campus for 7 minutes. I'm here. Why are you? My scratch.
When did I lose control of this class? If I ever had.
All right. Enjoy your birthday.
When did I lose control of this class? As if I ever had control.
About 5 minutes ago.
You're welcome. All right. Replace the DC source with a 40 hertz. What am I doing? Yep. This is the yellow one.
And you're going to defense of all.
Then where's the other lead? The blue, the second lead.
No, I don't think you need to.
Don't need to? All right. Use the oscilloscope to record the waveform for the function generator and VDS. So I think we do need to.
Okay.
Yeah. So remember, yellow will be for the function generator. The blue one will be for the VDS. Okay, check. Use your oscilloscope to record. Okay. Include the waveforms in the report. Did I take a picture? See you. Sorry, before, so everything has remained the same, right?
Yes.
So we don't need to like set up everything again. We just need to flip. What was?
No, you're good. Just take a picture.
Yeah.
The only difference is these leads are different, but you just need to not have that in the picture. It's fine.
Yeah. So let me just take this one for the AC.
Yeah.
Then give me a second, just quickly. I just need the mouse. That's all. Or yeah, I'll just use this black one. Whatever this connects to. Okay. AC taken. DC taken. All right, we can resume what we're doing before. Okay. So check. All right. Replace the DC source with VGG. So we've done that. So connecting these two together. So what's the next? 40 hertz. We've done that. 10 volts peak to peak. We've put that in. So how do you want me to plug this?
So we need one across the function generator. So one just from here to here. And
Okay.
one across VDS. So that's from the both sides of the so we need to get rid of the multimeter actually and have this plugged straight into here.
Yeah.
What's this? This is the other end multimeter.
Yeah.
So we need one end going here and the other end going to the other end.
Okay.
So that should go to the
To here?
yeah. As I understand it. And we need to turn on the function generator.
Yeah, I know. So replace the DC source. So I know the VG is like just across. Use your oscilloscope to record the waveform and VDS. Where's the diagram? So what we're doing is, so this would be the.
That's D and S is the bottom.
So that'll be yes, because these two. Okay, these two. That's why I said we don't need to connect them because they're already internally connected.
Yeah.
I believe we're good. Yeah, so both, yeah. Okay, that looks good to me. So replace the DC with the 4, use this to record waveform. So we're recording them for which sets of voltage with a stepwise one. Place the DC source with the 40 volts. Use the oscilloscope to record the waveform function. Professor, so for the exercise 2, what so for exercise 2, the VGG, that's to graph we're using the waveform generator now.
For what?
Exercise 2.
Okay, sure.
So which range of VDS values are we going to use?
Just use 10.
10.
Yeah.
So like this VGG is already at 10 volts peak to peak 40 hertz. So I should just set VDS to 10 and
To
take
10.
and that's all?
Mm-hmm. And take your screenshots
Okay.
or a screen. Show me what you see on the oscilloscope.
All right, run, I guess. If that's the case, 10 volts.
This needs to be 10.
No, we can switch this off, right? Is this connected?
This is the VDD. So this needs to still be 10 volts.
Is VDD meant to be connected?
Yeah.
Replace the DC source. Oh, you're right. Replace the DC source VGG. Yeah. That's weird. Okay. So you set this to 10?
Yeah.
Huh.
And we get nonsense.
And that's, oh no, I haven't switched. Oh, yeah.
All good things.
Okay, well, don't worry, we'll figure it out. Oh, look, it's working. I just need to fix. Then, how do I? Yeah, I think, yeah, then scale in. Oh, yeah, I don't even know if these are 1x. Are these guys set to, yeah, these are already set to 1x. Channel 1, 1x. Channel 2, 1x. The circle looks good. I think that's it.
Looks good to me.
Let me take a picture. Yeah, so I will make sure that this is good. Yeah. All right, let me show him. Sumaya, have you taken hardware software yet? I'm getting a bit tense for the senior classes. I'm getting a bit tense for the senior, like junior, senior classes. We're taking microcontrollers. Yes, that's microcontrollers. I heard that. It was good. So if I study more practice, you do good. But I heard it because his wife, that's why he gets messed up. Is that why?
Yes.
So look at how that's
Maybe I don't know how to use it.
No, but, no, I mean, with the electrical economics, nobody would. I would ask everybody, and be like, I have no idea.
And when the world really most vanished.
It's lecture. Read the book. That is my number one recommend.
I don't know where Dr. Stuff is.
Listen, he will talk in class, you will not learn a thing. Read the book. He insists that the manual is better than the book, but the book will teach you step by step, and the manual just gives you everything.
Okay.
So he's very much everywhere.
I read the book once.
I didn't read the book either because he told me not to. And I did. When I looked through the book,
It helps you.
it helped me a lot.
So I'll do both. I'll catch it in class and I'll do both.
Yeah, and then you can tell me how you feel about the book.
How's the lab?
It helps you. It makes you have time to get it.
He is very much, he gives you everything and then you just change a little bit of it.
Okay. Whoo! Are you guys love exercise too?
Yeah. What about you?
So he told me that there's only one image at 10 volts VDS. But this one here.
Yeah, that's your waveform. Is that two square waveforms?
Yeah.
Should not. Because look, this.
I saw, yeah, explain.
The yellow waveform is sinusoidal, and that should be what's coming out of your source.
Okay.
And then the blue waveform should be square because that's it triggering.
The blue one should be square.
I mean, if blue
Sorry,
is-
my source, okay, the VGS should be what?
source. But when it says
So VGS should be sine wave.
yeah, it should be a sine wave because it wants to connect it to not the source from, but the source of your voltage, which is sinusoidal wave.
I've seen, oh no, that's correct. Well, either ways, both should go to the return.
Yeah. So one should be sinusoidal, and one should be square. Two is reading
I still have. This is the craziest thing. So, where's your blue leaf? Where is your VDS? Where is it?
Is your reading? Yeah, so you just attach. Takes us off.
So this is the. And the multimeter is still connected to the circuit, right? Sorry, not the multimeter, the DC power supply is still connected to VDS.
You just replace it. But you're no longer measuring the waveform.
Yeah.
One of them should be legitimate waveform of your generator.
Okay.
So it should be attached to the columns of your generator.
Okay.
And then one should be VDS.
Okay. As we can see.
And then some of this. So we're measuring. This is the all across. But we're reading this to this. This is where this is attached to here. Right? And this is VDD, right? So basically what we're saying is VDD, measuring it here, at the resistor, and the potential compared to potential here compared to here is potential here.
I see your first one, your Excel. Did you recognize yours from
So I think he said VDS should be 10.
Correct. Yeah, that's usually small. Okay, that's all right. That's 98. Have you done the calculations for GM and the rest? 48. Okay, that's all right. Thank you. Okay. Maybe our diagram is correct. So the question is, does this make sense?
Thank you very much.
So this is the VDS. This is time. VDS is meant to start 10. Professor, I need to ask if you could help me understand what we're seeing here, because that's the graph we have. I could scale out for you. So the yellow represents the VGS,
Okay.
the blue represents the VDS.
Um,
I don't know. I don't think it looks right, but I'm not sure if, yeah.
so what, 40 hertz? I'm looking for a sine wave out of, oh, you don't have the function generator connected correctly.
Oh, you're right. You connected it to the sink.
Fun.
I can't believe you did that.
Wasn't me. Could you come check it now,
Why?
please?
What am I checking for?
You look at the wave.
Talk to me about what's happening here. What's the sine wave? Where's that
The
coming from?
sign represents the VGS and the blue represents the VDS.
Okay.
Yeah.
Okay. Explain to me what's taking place. So
right now, I believe, based on,
when this line right here,
yeah,
what does that line mean? This
yeah.
what does that line mean right there?
Blue. Does that represent the pinch off?
Well, you're
No.
measuring the voltage.
Well, that's VDS.
That's me.
At that point in time, VDS is 0. And when VDS is 0, that I'm trying to remember.
VDS is 0. Why is VDS 0? Or
VDS,
almost 0?
yeah, VDS will be 0 if ID is 0. If I'm not no,
Mm-mm.
I need to remember.
The key is right here. Let's follow the sine wave. And the sine wave is set at what value? Remember?
10 volts peak to peak.
Okay. So from here to here is 5. Okay. And see where those two lines intersect? They're intersecting about where?
Maybe like 2.5.
Mm-hmm.
That's when VGS is equal to VDS.
So when this reaches about 2.5, this sine wave,
Yes.
what happens to VDS?
That's VDS becomes 0.
Right. Let's flip this around. When this goes less than 2.5, what does VDS become?
It increases. So Okay, it's coming to me. Let me look at my notes.
Sure.
Oh, is that the so this is the IDS. So yeah. So this seems like the max current. Sorry, this is not current. We're talking about voltage here.
Yeah, you're measuring voltage.
Yeah.
When would you see maximum voltage across that MOSFET?
So maximum voltage from the GS or the DS.
Well, when would you see maximum voltage from drain to source? When's that going to be a maximum?
That's when in the saturation region. VDS.
Yeah.
When it's a maximum.
Yeah. When will there be maximum voltage from drain to source? It's when there's zero drain current, right? What's another way to say that? So the transistor's off.
So that's when the VDS is a maximum.
Right. Because the transistor is off. It looks like an open switch.
So yeah. So when the transistor is off,
Mm-hmm.
I have to write this down. So he said so this for a MOSFET.
Well, this is true for any type of
Transistor. So you said that when transistor is off, the VDS is a maximum.
And that's what Kirchhoff's voltage laws tell us.
So this is a maximum VDS. So you're saying that there is zero drain current. Okay, but there's a negative gate voltage at this point in time. But MOSFETs can't be in reverse bias.
Right, they can't be in reverse bias, but the only way you can turn on an enhancement, an N-channel enhancement mode.
Is if it's on. So that's why. So this, you're right.
Okay.
So in this region, this is negative. Therefore, the enhancement MOSFET is off.
Yep.
Therefore, this at the maximum. As it slowly begins to increase, this begins to decrease. Okay. Thank you.
You have to flip your brain around.
Yeah.
Good.
All right. I'll take a picture of this. All right. Yeah. You can share the Excel later. All right. Thank you. Please. Finally done. See that wave right there. And straight. That was a good one.
Have a good day.
See ya.